classes. So students, in the previous session we have discussed the synopsis part of the colloids. Okay, so in today's session we will solve the problems based on the colloids. Okay, so let's get started with the problems. So first we will solve the questions of the first level. Okay, now this is the first question, and the first question is saying that which one of the following is hydrophilic? Which one of the following is hydrophilic? What do you mean by hydrophilic? Hydrophilic means, see, first hydro means water, philic means loving, we can say, or having affinity. Having affinity. So water loving colloidal solutions or colloidal salts. Okay, now already in the synopsis part we know that all the metal salts, it may be like, you know, gold, silver, platinum, okay, iron, and all these type of metal salts, they are all hydrophobic in nature. Okay, so among these, first you have to identify which is not a metal salt, then that will be your hydrophilic. Remember this always. Naturally existing colloidal salts, they are hydrophilic in nature, and metal salts, they are generally hydrophobic. Means metal salts are having phobia, means they don't have any affinity for the water. Okay, so first let us understand. Okay, see, barium hydroxide, it is containing metal only. Okay, this is hydrophobic in nature. Second one, arsenic sulphide, again arsenic sulphide is negatively charged, again it is a non-metal sulphide, so again it is also hydrophobic. Now third one, starch solution. Now starch is naturally existing one, so this is the correct answer. Okay, even the fourth option, if you see, it is saying that silver chloride salt, so again silver is coming. So all the metal salts are what? They are hydrophobic in nature. So only this is not containing any metals, so this is your answer. So for the 14th question, the answer is third one. Okay, so next we will move on to the next question, 15th question. Okay, what is 15th question is saying? Which one of the following is a hydrophobic? Okay, just now we have discussed what is meant by hydrophobic. What is meant by hydrophobic? Hydro means water, phobic means phobia, which means fear, which don't have a affinity for the water, we call them as a hydrophobic. Again, in the previous example we have seen that starch solution was hydrophilic and rest of the options were what? Hydrophobic. Okay, now if you see here, again here they are asking you hydrophobic, means you have to identify the metal salt, then that is your answer. Okay, rest all, if they are all natural, then they will be hydrophilic. Okay, let's apply that logic here. See, starch solution, just now we have discussed, it is hydrophilic in nature. Then comes the gum, which is also hydrophilic. Then comes protein, even protein is also natural one, so therefore this is also hydrophilic in nature. Then comes arsenic sulphide solution, so your answer will be option number 4. Why? Because it is metal salt which is negatively charged, therefore it is having phobia towards the water, so it is your hydrophobic salt. Okay, so just remember that logic. Okay, then moving on, that is 16th one. What is the 16th question? Is saying that the zigzag motion of the colloidal particle was first observed by. First thing we have to understand what is meant by zigzag motion. Okay, the zigzag motion of colloidal particles is called as Brownian motion. We know this, isn't it? It is called as Brownian motion. And why the motion, zigzag motion of colloidal particles is called as Brownian? Because the scientist who observed the zigzag motion of colloidal particle, it was Robert Brown. You have to know this. Okay, Robert Brown, this we have discussed in theory as well as in synopsis part. Now who was Robert Brown? Robert Brown was a botanist. He was studying regarding he was studying the pollen grains when added into water. He observed that those pollen grains were continuously randomly moving in all directions. They were not static. Static means they were not staying at only one place. Okay, so then he thought that as the size of the pollen grains comes in between that of the colloidal particles, so even the colloidal particles might be moving in random directions. Okay, therefore the zigzag motion of colloidal particles is called as Brownian motion. Why Brownian motion? Brown means it was the surname of the scientist and the complete name is Robert Brown. So among these the correct answer will be Robert Brown. Then we'll discuss the other option also. Who was John Tyndall? You know, the person who observed Tyndall effect. Okay, what is Tyndall effect? The scattering of light. Okay, so he, I mean, in a colloidal solution, okay, when the light is passed, okay, this part, the path of the light becomes visible, isn't it? The path of the light becomes visible. Why the path of the light becomes visible? Because the colloidal particles will scatter the light. So this effect was observed by John Tyndall. So John Tyndall observed Tyndall effect. Robert Brown observed the Brownian or zigzag motion. Then Zsigmondy was a scientist who discovered the microscope from which you can see the zigzag motion of the colloidal particles. Okay, then last one is Ostwald's dilution process that comes in your electrochemistry part, so it is not concerned here. So the answer is Robert Brown now. So moving on to the next question, that is 17th one. Okay, so which one of the following is lyophilic colloid? Again, see, again what you have to identify. Lyophilic they are asking means you have to observe which is naturally existing, which is not a metal sol. Which is not a metal sol, that is lyophilic in nature. So if I see gelatin, okay, gelatin is the correct answer then straight away, because sulfur, these are metal and non-metals only. So these are hydrophobic, or here lyo means what? Lyo means liquid. Liquid loving, philic means affinity, or liquid loving means gelatin which is naturally existing. These are all what? Metal salts or non-metal salts. So these are lyophobic in nature. Okay, so question number 17, the answer will be first one. Then second. Moving on to the 18th question. Okay, among the following, which colloid does not exist? Okay, which colloid does not exist? First look into the option, what it is saying. Okay, it is, I mean, the question is saying which type of colloid it should be. Among the following, which colloid does not exist, or which type of colloid does not exist means what? So we know that a colloidal solution contains two parts. One is dispersed phase and another one is dispersion medium. Okay, so dispersed phase can be what? Your solids, liquids and gas. Again, dispersion medium can be solid, liquid and a gas. Okay, we have seen this. Okay, that solid may be present in solid, solid is present in liquid. Okay, solid can also be present in gas. Okay, so then again, if you see liquid as a dispersion medium, liquid as a dispersed phase is present in solid, liquid is present in liquid and liquid is also present in gas. Okay, then gas as a dispersed phase is also present in solid, gas is also present in liquid, but gas does not present in gas. This type of colloid does not exist. This type of colloid does not exist. So your answer should be this, that there is no colloid exist in which gas is present in gas. Okay, so among these four, what is the option then? The option is your first, that is gas in gas type. Okay, gas cannot be present in gas. Okay, so this is the answer now. Okay, so then moving on to the next question. Okay, easy one, that is milk is an example of what type of colloid? Okay, milk is a type of colloid in which dispersed phase and dispersion medium both are liquids. Both are what? Both are liquids. When dispersed phase and dispersion medium both are liquids, it is called as emulsion. Okay, so in case of milk, what is the dispersed phase? It is the liquid fat and the dispersion medium is water. So emulsion is an answer. So milk is an example of emulsion. Okay, then see, it cannot be a gel. Why it cannot be a gel? See, you should see, if you know the proper if you have the proper knowledge of what is the dispersed phase and dispersion medium, you can clearly solve. Now milk cannot be a suspension. We know that suspension. Why? What are suspension? What are suspensions? We know that which cannot pass through the normal filter paper. Milk can pass through normal filter paper or no? Yes, it can pass through the normal filter paper. Okay, so milk cannot be suspension, milk is not even a solution, and milk is not even a milk cannot be a gel. Why not gel? Because in gel, dispersed phase, first dispersed phase is liquid and dispersion medium is solid. Okay, gel. Okay, what are the example for gel? Your gel gums you have seen. So jam will come, jellies will come under this. So milk is not like jellies. Okay, so milk is an example for emulsions. Okay, moving on to the next question. Fog is a colloidal system. Fog is a colloidal system of what type? Okay, so again you have to remember, fog, in what is fog containing? In fog, water vapors are present. Water vapors are present in air, present in air. So here water vapors, here the water vapors are your dispersed phase and air is your dispersion medium. Means air is in gases, water vapors means liquid. Okay, so fog is an example of liquid in gas of type of colloid. So among this, which is that? Second option is saying that liquid in gas. Okay, so gas in liquid, no, it is not in gas in liquid of type. Gas in liquid is what type of? It is foam. So gas in gas does not exist only. So gas in solid, that is also not in a option. Okay, so liquid in liquid, that is our answer. Okay, the next one, question number 21. Okay, it is saying that the conversion of a cream. Okay, it is saying what? The conversion of a cream into a butter. The conversion of a cream into a butter by churning is an example. Okay, so cream means here, see, butter means buttermilk you have seen. Okay, buttermilk, butter means buttermilk you have seen. So let's say churning means when you ನಮ್ಮ ಹಳ್ಳಿ ಕಡೆ ಎಲ್ಲ ಮಾಡ್ತಿರ್ತಾರೆ ನೋಡಿರಿ, ಏನಂತಂದ್ರೆ ಈ ಮೊಸರನ್ನು ತೊಗೊಂಡು ಮೊಸರನ್ನು ಕಡ್ದಾಗ ಏನು ಸಿಗ್ತದೆ? ಮಜ್ಜಿಗೆ ಸಿಗ್ತದೆ. ಸೊ ಅದಕ್ಕೆ ಏನು ಕರೀತಾರೆ ಆ ಪ್ರೊಸೆಸ್ಗೆ? ನಾವು ಕಡಗೋಲ್ ತೊಗೊಂಡು ಅದನ್ನ ಏನು ಮಾಡ್ತಿರ್ತಾರಲ್ಲ ಹಳ್ಳಿಯೊಳಗೆ ಅಜ್ಜಿಯವರು, ಈಗೂ ಮನೆ ಕೆಲವೊಂದು ಸರ್ತಿ ನಮ್ಮ ಮದರ್ ಅದು ಮಾಡೋದು ನೋಡಿರ್ತೀರಿ. ಸೊ ಅದಕ್ಕೆ ನಾವೇನು ಕರಿತೀವಿ? ಚರ್ನಿಂಗ್. ಅಲ್ಲೇನಾಗ್ತೈತಿ ಅಂತಂದ್ರೆ ಕ್ರೀಮ್ ಒಳಗೆ ಏನಾಗಿರ್ತೈತಿ ಅಂದ್ರೆ ಇದು ನಿಮ್ಮ ಮೊಸರದ ಕೆನಿ ಅದು ಫ್ಯಾಟ್, ಹೌದಾ? ಅದನ್ನು ನೀವು ಅದರೊಳಗೆ ಏನಾಗಿರ್ತದ? ಆ ಕ್ರೀಮ್ ಅಂತಂದ್ರೆ ಕೆನಿ ಒಳಗಡೆ ದ ಕ್ರೀಮ್ ಒಳಗಡೆ ಏನಾಗಿರ್ತದ? ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸ್ ಆ್ಯಂಡ್ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಮ್ ಏನಾಗಿರ್ತಾವ ಅಲ್ಲಿ ಒಂದಕ್ಕೊಂದು ಹೊಂದಾಣಿಕೆ ಮಾಡ್ಕೊಂಡಿರ್ತಾವ. ಅಂದರೆ ಸಿ ದೇರ್ ಈಸ್ ಒನ್ ಎಮಲ್ಸಿಫೈಯಿಂಗ್ ಏಜೆಂಟ್ ಇನ್ ಮಿಲ್ಕ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಕೇಸಿನ್. ಓಕೆ, ಕೇಸಿನ್. This is an emulsifying agent. Adu present irtadu. Where in the milk there is an emulsifying agent called casein, which is holding both the liquid fat and water together. When you churning is a process wherein you will separate both. Okay, so churning is a process wherein we will be separating both. Okay, so when we are separating both the dispersion medium and dispersed phase, that part we call it as de-emulsifying. Emulsification means which holds. The emulsification is a process wherein dispersed phase and dispersion medium are held together. Okay, then when I am separating these two, dispersed phase and dispersion medium means it is the opposite of emulsification, then we call it as a de-emulsification. So among these four the answer will be second, that is de-emulsification. Okay, so de-emulsification is the answer. Okay, option number 2. Moving on to the next question. Okay, next question is saying that random motion of colloidal particles is known as. Okay, random motion, just now we were discussing in the previous questions we have seen that random motion means zigzag motion of colloidal particles is known as what? See, what is a dialysis? Dialysis is a purification method. Okay, what is the dialysis? The dialysis is a purification method. Then Brownian movement, yes, this is your correct answer. This is your correct answer. Dialysis is a purification method. This cannot be the answer. Electroosmosis. What is electroosmosis? It is a process wherein we will pass the electric current through the colloidal solution, and in that when we pass the current through the colloidal solution, colloidal particles does not move. What is moving? The dispersion medium particles are moving. That is called as electroosmosis. Then what is Tyndall effect? Tyndall effect, we know that the colloidal particles will scatter the light. Okay, so these three cannot be. So random motion of the colloidal particles is called as Brownian movement. Okay, so option number 2 is again the answer. Then moving on to the next question. Yes. Okay, when a strong beam of light is passed through a colloidal solution, the light will, just now we have discussed, colloidal particles will scatter the light. Okay, so first one is only your answer. Okay, light will be scattered, passed unchanged. See, only in true solutions the light will passes without any changes. Okay, and they are asking about when a light is passed through a colloidal solution. Okay, therefore the light will be getting scattered. Third one is saying giving a rainbow. No, we will not observe the rainbow. Then fourth one is none. That is not the answer. So the first one is our answer. Then moving on to the next question. Okay, we'll move on to the level 2 questions then. Okay, level 1 questions are over. We'll move on to the level 2 questions. Okay, in that the first question is saying that which one of the following is not a colloid? 11th one is what it is saying. Which one of the following is not a colloid? Yes, let us find out. Now, milk is a colloid. Milk is what type of colloid? It is an emulsion. Then blood is also a colloid. Okay, blood is also a colloid containing hemoglobin in others. Okay, it is also a colloid. Okay, ice cream, just now we have seen, cream is also a emulsion only. Emulsion only. It is like oil in water. Okay, it's a cream. Then urea solution. Yes, this is not an colloid. This is not an colloid. So this is not the colloid. So that is our answer. Because in the question they are asking which one of the following is not a colloid. These three are colloids and this is not a colloid. Okay, so next question. Okay, the next question is asking that the difference between lyophilic and lyophobic colloid is in there. See, when a colloid means the particle size remains between 1 nanometer to 1000 nanometer. Isn't it? Be it a lyophilic colloid or be it a lyophobic colloid, but the size of the colloidal particle lies in between this only. Okay, so particle size does not differentiate between lyophilic and lyophobic colloid. So this is not our answer. Then behavior towards a dispersion medium. Yes, this is our answer. Why? Because in lyophilic colloid, what is happening in lyophilic means liquid loving. So behavior towards your liquid is affinity or loving is there. Lyophobic means affinity. If I write here affinity, so here I can say that it is hatred nature. It is the hatred nature. So behavior towards the dispersion medium is the correct answer. Why? Again, filterability. Be it any type of colloid, it will pass through the normal filter paper, but it cannot pass through the animal membranes. Okay, or starch paper. Okay, then fourth one, none of this is not the option. So the answer is behavior towards the dispersion medium. Then next one. Okay, which one of the following statements is correct for a lyophilic soil? Okay, they are asking now which of the following statements is correct for lyophilic. So you have to understand in a lyophilic soil, first thing is dispersed phase and dispersion medium are having affinity towards each other. Okay, then see what are the options what they have given. Let us see that. Okay, lyophilic salts, they are not, first option is saying they are not easily solvated. Solvated means, see, colloid, this is suppose my colloidal particle. Solvation means water molecules will surround it like this. Surrounding of water molecules is called as solvation, and we call the colloidal particle is solvated. So see, if my colloidal particle is a dispersed phase and water is my dispersion medium, then if they are lyophilic means both dispersed phase and dispersion medium are going affinity, means definitely the colloidal particle is well solvated. It is well solvated and very easily solvated, but it is here saying that lyophilic salts are not easily solvated. So this is not the answer. Solvated means you got the idea, means dispersed phase is well surrounded by the water molecules. Okay, if suppose my dispersed phase is not having affinity, then it is not well surrounded, then it will be having some charges first around it and then the water molecules around it. So but now here lyophilic means definitely it is well surrounded or very easily surrounded by the water molecules. Next one, lyophilic sol. It is carrying charge. Yes, of course it is also carrying charge. Then third option, let us see, the coagulation means precipitation. The precipitation of this sol is irreversible in nature. No, you can once you convert the lyophilic solve into a precipitate, again you can convert that into a lyophilic sol. It is not that irreversible, it is reversible. In fact, you can make them chargeless, you can again make them charged. Okay, so this is also not the correct answer. Then fourth one, it is saying it is quite stable in solvent. Yes, in lyophilic sol, no, they are carrying charges, but this does not that strong, but I'll go for this one. It is quite stable in solvent. Yes, it is quite stable in solvent. This is most, what we can say, among these two, this is the most correct answer. Sometimes the lyophilic salts will be carrying charges, but this is more easier, means based on behavior. If I have to say, both the dispersed phase and dispersion medium are having affinity towards each other. So this is the correct statement for the lyophilic salt. Okay, so option fourth is the correct answer. Next, moving on to the next question. Okay, so the next question is saying, okay, the movement of colloidal particles under the influence of applied electric field is called as. Okay, the movement of colloidal particles under the influence of applied electric field is called as. See, filtration is a process of purification of colloidal particles. So this is not the answer. Okay, see, in filtration again there are two parts. Okay, dialysis and electrodialysis. Okay, so in electrodialysis we will be using electric current, but there the dispersed phase is moving. Okay, so this is not the correct answer actually. What filtration is, the movement of colloidal particles under the influence of applied electric field. This is a filtration process, but the movement, we have a different name for that. The movement of dispersed phase particles under the influence of applied electric field. Okay, electrophoresis. This is our answer. We have studied this. Okay, what is electrophoresis? Electrophoresis is a phenomena in which when the electric current is applied in a colloidal solution, then we know that the dispersed phase particles will move towards the electrodes and get discharged. What is meant by electroosmosis then? Electroosmosis means what? Instead of dispersed phase, if the dispersion medium particles move, then it is called electroosmosis. Remember this part. Okay, then again see, dialysis is again a purification method. This cannot be answer. Ultrafiltration, this is again filtration process or purification process. So this is not the answer. Electrophoresis is our answer. Okay, next question. 15th question. It is saying that the reason for exhibiting Brownian movement by the colloidal particle is. So why the colloidal particles are always in a random zigzag motion? Okay, see, first one, it is saying that bombardment of colloidal particles to the dispersed medium. Yeah, it is correct actually. Okay, but let us see the other options also. Scattering of light, no, light gets scattered because of the colloidal particle, but because of light the colloidal particles are not in random motion. Okay, that is not the correct answer. Then option number 3, charge of the colloidal particles, no. Yes, of course all the colloidal particles are charged or neutral, but charge does not make the colloidal particles move in random direction. So this cannot be the answer. Then fourth option is saying that fast moving colloidal particles means this cannot be even the answer, because once the colloidal particles are colliding with each other, obviously then onwards they may be moving fast. Okay, so all these three are not the answers. So bombardment of colloidal particles with the dispersed medium, this is the answer. So option number 1. Okay, so next Question number 16. Okay, what it is saying? The charge on the colloidal particle is due to, see, we know that the colloidal particles will be having definitely either positively charged or negatively charged, but the charge comes to preferential adsorption theory. What it is? It is called as preferential adsorption. Okay, preferential adsorption means, see, we know that if AgI is my PPT, if it is a precipitate, if I have to convert it into a colloidal solve, or if I have to make it colloidal particle, AgCl, if I take AgCl, okay, then AgCl is a PPT. Now to just convert this PPT into colloidal solve, either I have to add KCl or again I have to add AgCl. Okay, why? Because K plus Cl minus. Now here to these two, whatever is common electrolyte, that electrolyte we have to add. See, between silver chloride, it is containing chloride here, so this might absorb chloride, so it will become negatively charged like this. Okay, now if I add AgCl, then silver is present, then instead of chloride, okay, they will absorb Ag plus, then they will become positively charged. To this, whichever is common, they will adsorb that only. This question is very important, or this concept is very important. Preferential means this precipitate prefers only those charges which are in common with the constituent of the precipitate. This, okay, you have to remember. Okay, then see, presence of an electrolyte, charge on the colloidal particle is due to presence of electrolyte. See, if excess of electrolyte are there, then what will happen? It will again get converted into precipitate. So this is not the answer. Then second one, very small size of the particles. No, if the colloidal solution particles are very small, then they are called as solutions, not the colloidal particles. Then third option, adsorption of the ions from the solution. This is the correct answer. Then none of this, it's not that. Okay, present of excess of electrolyte will cause again what? Precipitation. Okay, remember that. Okay, option 3 is my answer. Then moving on to the next question. Okay, next question is saying that which of the following salts is negatively charged? So among these, which of the following salts you have to identify which is negatively charged. See, I had already given you the table. Okay, what are the things which will come under positive charge and what are the things will come under negative charge. See, all the hydroxides, be it ferric hydroxide, aluminium hydroxide, and even potassium hydroxide, sodium hydroxide, all the hydroxide forms will be always positively charged. Hydroxides are positively charged. Okay, then what are negatively charged? Sulphides, then metals like platinum, gold, silver. These are the metals which are present as negatively charged. These are negatively charged. Okay, so hydroxide are positively charged. So now these two are positively charged. Now fourth option, what it is saying? Silver iodide. Now silver iodide, what is silver iodide? AgI. Silver iodide means AgI in silver nitrate solution. So what is a silver nitrate solution? Means AgNO3. So NO3 minus Ag plus. So AgI will adsorb what? This will adsorb Ag only. Then it will become positively charged. So this is also positively charged. All these three are positively charged. So sulphide, negative charge. This is our answer. Okay, so we'll move on to the next questions. Next is, which of the following ions which of the following ions is most effective in the coagulation? Coagulation also we can say, or even you can say precipitation. Okay, I'm writing in shortcut, precipitation. Which of the following ion is most effective in the precipitation of an arsenic sulphide? What do you mean by arsenic sulphide? AS2S3. Okay, means S3 means sulfur carries a -2 charge, there are 3 means it is carrying -6 charge, AS2 means it is carrying each arsenic is carrying +3 charge. Okay, so among this, which will be most effective? See, most effective means it is carrying only single charge. Okay, so we require lot amount of potassium. Okay, then comes magnesium, it is carrying +2 charge. Okay, when compared to this is required very little. Then comes aluminium, it is carrying +3 charge. So among all the options given, even calcium is carrying the +2 charge. Okay, so among all the given ions, which is having higher valency or oxidation state is aluminium. Higher the oxidation state, minimum amount is required. So that minimum amount is called as Filtration value. Filtration value or fluctuating value. Okay, that part again we will discuss. Okay, so among this ion which is carrying the highest oxidation state, it is the aluminium. So this is the most effective one. Okay, this is the most effective one. This requires higher more amount. This also compared to this require less. Okay, these two require the same amount, but this is having higher oxidation state, so this is required in less. So this is most effective, aluminium. Okay, then moving on to the next. Okay, which of the following ion is most effective in coagulation of ferric hydroxide? Just now we have discussed hydroxides are what? They are positively charged. They are positively charged. Then we require negatively charged. Now just like in the previous example, we have to see a negatively charged particle which is carrying higher oxidation state. Now these three, if you see, they are carrying only one negative charge, but sulfate is carrying what? 2 negative charges. So this is most effective one. Okay, ferric hydroxide, yeah, it is positively charged. Then next question is saying that the emulsifying agent in milk is casein. This you have to remember. Okay, this you have to remember, easy. Casein is the answer. The emulsifying agent present in milk. So many times in board examination also 1 marks question they have asked. The emulsifying agent present in milk is casein. Okay. Question number 21. Okay, colloidal medicines are more effective because they are cheap, they are easy to prepare, the germs move towards them, they are easily assimilated and absorbed. All are correct, I guess, but I guess they have to be, they are easily assimilated and absorbed. Okay. I guess this only. Cheap. All are correct, but I'll go for, and as based on the colloidal system, so I'll go for they are easily assimilated and absorbed. Okay. Next question, question number 22. Okay. So which of the following has maximum Filtration value for a negatively charged salt? Okay, Filtration value. What is meant by Filtration value? Minimum amount of millimoles. Okay, millimoles. Okay, Filtration minimum amount of the electrolyte required. Okay, that we have to see now. So among this, see Na plus maximum. Okay, they have asked maximum. Maximum means, see, which, first let me write it here. If you look into the charges here, Okay, now these are the charges of the positively charged metal salts, because see they are saying that the colloidal salt is negatively charged. Okay, if they ask you which of the following is required minimum flocculation value, minimum flocculation value means among these four which is required in minimum amount, then the answer will be the colloidal particle which is having higher oxidation state. Then minimum value means this is our answer. Okay, stannous chloride. But they have asked maximum means which among the following is required in maximum amount for the precipitation of negatively charged salt. So which is carrying lower positive charge, that is required in maximum amount. You understanding it? So among these four, which is carrying the least positive charge, sodium is carrying the least positive charge. So this is required in maximum amount. So the flocculation value of sodium chloride will be maximum for the precipitation of a negatively charged salt. Okay. Okay. Then moving on to the next. Okay, again the same type of question is there. Now instead positively charged, it is negatively charged. Okay, so which of the following ions has a maximum flocculation value? Again they are asking you maximum flocculation. Okay, so now in this C, if it is carrying only one single negative charge, this is carrying two negative charges, this is 3, this is 4. Okay, this will be carrying this will be carrying -4 outside, means you require potassium ferrohexacyano. Okay, means here it will be +2, it will be +2 charge, so never the mind. So we require maximum amount, right? Which among the following has the maximum flocculation value? Okay, which is carrying the minimum negative charge, that will be having maximum flocculation value. So among this, which is having minimum negative charge, this is having the minimum negative charge. So this is required in maximum amount. Okay, so moving on to the next one. Okay, 24th, the flocculation values of KCl, magnesium chloride, MgCl2 it should be. Okay, MgCl2, yeah, MgCl2, then chromium, this has to be C, this has to be MgCl2, and this has to be chromium chloride, and stannous chloride, this has to be 4. Okay, for a negatively charged salt, again see all these are, see potassium is +1 charge, magnesium +2, chromium is +3, and strontium here it is carrying the +4 charge. So which is what flocculation values are in the order, right? Are in the order. See, they have not mentioned increasing order or decreasing order. They should have mentioned, okay, increasing order or decreasing order. Let us see the example how we will solve this. Okay, if you see the first option, it is saying that, see, this is +4, +3, this is +2, then it is +1. So first option, if you see, it is the increasing order, means when the charge is more, minimum amount it is requiring. This has to be Cl4, huh? Okay, so minimum amount stannous chloride is requiring, then after this is minimum, then after this is minimum, then after this is minimum. So this can be also a correct answer. Okay, if they had asked you in the which among the which order is increasing order or decreasing order. So if you see, this is the decreasing order. Okay, means this required very less, this required, then after this is required very less, then after this is required this is required very less, compared to this is required little bit more, then this is little bit more, then this is required in more amount. So this can also be present. Now option 2 cannot be the answer, because all of them are carrying different charges, so their flocculation values cannot be the same. So this cannot be the answer. Then third one, if you observe clearly, then no, here only wrong. If you see potassium is carrying +1 and magnesium is carrying +2. So +2 cannot be less than +1. So this is not the answer. Then the fourth one, if you see, it is the reverse of first one, +4, +3, +2, then it is +1. See, it is in decreasing Fluctuation value, isn't it? Fluctuation value is, this is in decreasing order. This is in decreasing order. This is in increasing order. This is in increasing order. Okay, this is in increasing order. This is in decreasing order. So both are correct, but here they have not mentioned which is decreasing or increasing order. We can go for this one. I have checked the book, so I am saying it. I have already solved these questions. So I am saying they have said that this one. So this is increasing order. In the increasing order means this will be correct. Okay, means this is required more amount than this. This is required the least amount. This is required the highest amount. Okay, then the last question. Okay, the last question, what it is saying, let us see. Okay, little bit big question is there, but let us solve this. What is it saying? That the Fluctuation value of an electrolyte, okay, the Fluctuation value of an electrolyte is, okay, the amount of electrolyte in grams required to bring about coagulation of 1 liter of colloidal salt. So they are saying in grams. So grams is not the answer, because Fluctuation value is what? The millimoles, the amount of the electrolyte required in millimoles for the precipitation of 1 liter of colloidal salt. So you have to find among this which is, see, the second option is saying that the amount of electrolyte in milligrams to bring about coagulation of 10 ml of colloidal solution. This is actually gold number. So this is not, because they are saying milligrams. Okay, then option number 3, the amount of the electrolyte in millimoles. Yes, the amount of electrolyte in millimoles required to bring about the coagulation. Coagulation means precipitation. Remember, PPT. Okay, we call it as PPT, precipitation, coagulation or precipitation of 1 liter of the colloidal salt. So this is the answer. Okay, the reciprocal of coagulating power. No, that is not that. So among these 4, this is the answer. Okay, so just remember, gold number and Fluctuation values might confuse. In gold number, you will be requiring the amount of electrolyte in milligrams. Okay, and third one, that is Fluctuation value, is the amount of electrolyte required in millimoles. This is important. What it is? Millimoles. Okay, if you can remember the definitions, that is better. Okay, so in today's session we have solved the level 1 and level 2 questions. So in the next session we shall see the problems in NCERT examples, then the questions asked in Karnataka CET. Okay, so students, let's meet in the next session. Thank you so much, students.